So if you want to do the shortcut, right, for this, then, okay, so the reason why you can do the shortcut is u is negative 4x and its derivative is a constant, negative 4. So you just take an integral of this, right? E to the blah, right? The integral will be, again, e to the blah, right? So the shortcut is, this will be e to the negative 4x over the derivative of u from 0 to 1. So that's e to the negative 4 over negative 4 minus e to the 0 over negative 4. And look, magically, this is just 1/4 on this end, right? So it's 1/4 minus e to the 4 over e to the negative 4 over 4. Okay, so either of these is okay. All right. For values of x greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of a function f. Which of the following must be true? So when I see a question like this, I instinctively do this. Okay? Okay, so now, which of the following must be true? Okay, what does it mean that you have a horizontal asymptote? Where do asymptotes take effect? Close to the origin or at the infinities? At the infinities. So this means that the limit of f of x as x approaches infinity is the same as, limit as x approaches negative infinity, and that's equal to 2. Okay, that's what the asymptote means, really. So, is it absolutely necessary for f of 0 to be equal to 2? No. Is it absolutely necessary that f of x cannot equal 2? Is that true? Is it true that that y can never be 2? Can the graph ever cross the asymptote here? Yes, it can cross the asymptote. So it's not true that it can. Is it true that f of 2 is undefined? Not necessarily. The limit as x approaches 2 is infinity. That's not the one either. How about this one? Yeah, that's the one. Okay. Oh, look. Good old quotient rule. All right. So low d high times 2. Take high d low. Cross the line. Square the low. And then this one, it's basically just algebra after this. You do the algebra and you get that it's D because the x's go away.
I have a question.
Yep. Yep.
I never understood why it's an asymptote if you can cross it.
So vertical asymptotes are points where you have an infinite discontinuity. Okay? So by definition, if you have, for example, y equals x over x plus 2, there is no way x can equal negative 2 because the function will be undefined. You can't, so that's the reason why, because it's undefined there, you can't cross a vertical asymptote. The definition of a horizontal asymptote is the limit of f of x as x approaches positive infinity or negative infinity. That means by definition, the asymptote will only happen at the infinities. There is no requirement here that says y is undefined.
I remember that.
Yep,
Yeah.
yep, good. Okay.
There's no point at that. You can't equal that point.
Only at the infinity.
Only at the infinities. So if y equals 2 is a horizontal asymptote, the graph could vary. Oh, it froze. Oh, okay. So the graph is only required to follow the asymptote at the infinities. Otherwise, it can cross the function a million times. I mean, it can cross the asymptote a million times.
Is there a point though? Is there a point at that asymptote when it crosses it?
No, I mean, there isn't, like, it's just, you know, it's just like if there was no asymptote. In fact, maybe a better way to draw that even is to not even put it there. So like here's a function, blah, it's doing all this stuff, and then the asymptotes are only here at the infinities. They don't even really exist before that. Yeah, okay?
I remember that now.
Yeah, so if you were like to see a function and its asymptote, that's what it would look like. Oh my, of course, yes. Okay, something about that, like when I see that function, like my heart just like, it just like sort of like expands. I'm just like, oh my God, how beautiful. So what do you think? What's the integral here? Negative cosine x? Sure. From 0 to pi over 4. Negative cosine of pi over 4 minus negative cosine of 0. So negative root 2 over 2 plus 1, right? So that's D. And do you see how, you know, it's very common for a student to say that the integral of sine is positive cosine, right? And then, so you'll be off by a negative. And then here too, right, it's very common to, you know, just like miss a negative. So you see how in here they have all the permutations, right, all of the possibilities. And of course, you know, it's very common for us when we're stressed to say, oh, cosine of 0, that's just 0. And of course, those possibilities are here as well, right? So, I know. Okay, so this one, but see, like they make up for it with this one. Because look, limit as x approaches to infinity. What is it? We only look at this, right? So that's a fourth. Yeah, so far so good. So far we're having fun. Okay, here we go. The graph of f prime, the derivative of the function f, like they're emphasizing that one, is shown above. So what I do is highlight or circle or something that, so that I know that this is not f, this is the slope or the derivative of f. Which of the following is true about f? And if you like, let's look at this for a minute. Graph of f prime, this is f prime. So look, f prime, the derivative is positive all the way up to 0, right? So f prime is positive this whole time. F prime is negative this whole time, right? What does that tell me? Look, I haven't even read the question yet. What does that tell me? What is the function doing in the red region? Increasing. What is the function doing here? Decreasing. Now, what else do I know? I know that here, f prime is decreasing. What does that tell me about f double prime? F double prime? Right, f double prime is negative, so f is concave down. Do you see that? Do you see the difference?
It's increasing in the negative direction? Is that what it's happening? In this, what happens at
It's increasing and concave down from here to here.
It's increasing.
Oh, so is that f double prime?
F prime is decreasing, so f double prime is negative.
Does that just mean that f prime, which is a slope, has a negative slope? So
right, so f double prime is negative.
So it's still in the, it's still positive, it's just going down?
We don't know if the graph is positive or negative.
Okay.
Okay, so let's see what we know here. F prime is positive, that means the function is increasing, right? But the concavity here isn't changing, okay? But here it's concave down. Okay, so let's look at some questions. F is decreasing from negative 1 to 1. Is that true? No. No, because we just said that F is increasing here, F is decreasing there. F is increasing from -2 to 0. Is that true?
Yeah.
Yes. F is increasing from 1 to 2? No. F has a local maximum at 0.
No.
No, why not? Because it's oh, I read that wrong because I was like, wait, that is true. F has a local F has a local minimum. No, because it's increasing then decreasing, so it is a maximum there. F is not differentiable at x equals -1 and 1. That's what do you guys think about that?
You can see it.
No, F is differentiable because it exists, right? F prime exists. So B is the only one. Okay. Oh, look. An integral. What do you suggest we do here? Huh? Yeah, good. Good call. How? U substitution. What is U, you ask? What is it? X cubed. Because then du is 3x squared dx. Oh my God, like how perfect. So this is cosine of u, and then times 1/3 du. So -1/3 sine of u plus c. No, positive. Oh my God, look, I fell into it. Okay, so this is b. Okay, so here we have ln of this beautiful complicated thing. We want f prime of 0. So first let's find f prime of x. Okay, what's the derivative of ln? 1/1. Okay, so the derivative of ln of something is 1 over the something times the derivative of the inside. So that's 1 minus 3 e to the -3x. Right? Yes? So now at 0, 1/0 plus 4 plus e to the 0. So it was 1 plus the derivative of e to the -3x is e to the -3x times -3. Okay, so now it's 1 plus e to the 0 times -3. That's -2/5. A. Okay. So this next page, these are pretty common. The function f has a property that f of x is negative, f prime is negative, f double prime are all negative for all real values of x. Which of the following could be a graph of f? Okay, before I even look at this one, because that'll make my head spin, I think to myself, what does each of these things mean? What does it mean that f of x is negative? Where does the graph sit? Below the x-axis. What does it mean that f prime of x is negative? It's decreasing. What does it mean that f double prime is negative? Concave down. So now I know what to look for. Now I want a graph that sits below the x-axis, is decreasing, and concave down. Is it A? No. B?
Yeah.
Could be B, but check some of the other ones as well, because you may have like seen it incorrectly before, right? So this one is increasing, can't be. This one's doing all sorts of things. I don't know what that's doing. This one's not even below, so it's B. Okay. Okay, and so look at this one. Huh? Tell me.
No, it's Ben.
So,
Like,
you always
his
bring
giant
you-
water.
Your dad always has
But
this
it's, like,
massive water bottle.
spilling.
I don't know how to drink this. It's so big.
You didn't plan on how it was gonna. You didn't.
You need a big straw.
I'm trying to hide it.
Yeah, I don't.
Screencast for that though. Okay, so if u is this, what is this going to be equal to or equivalent to? So it's definitely going to be root u, right? Which, okay, they all have a root u, so that's no help. But but then you need to change the bounds, right? So 0 will give you a 1, 2 will give you a 5. So it's either C or E. And why would it be one over the other? Huh? Du, right? Exactly. When you do du, then it's a 1/2. You're gonna get an additional 1/2, right? Speaking of the rate of change of volume in a tank. Okay, the rate of change of volume of water in a tank with respect to time is directly proportional with the square root of the volume. There's the magic phrase. So now you pause and you say, what is proportional to what? Rate of change of the volume is directly proportional to the square root of the volume. So rate of change of the volume. Okay, now I'm going to write the highlighted parts only in a mathematical statement. dV dt, that's the first one, is directly proportional to equals k times the square root of the volume. Do you see that? Do you see how it's like scientific, methodical, beautiful? Yeah.
Well, I can't remember what's K.
So whenever you have black is directly proportional to, yeah, it's K. K is the, so this means, yep, equals K times. Okay. Oh, look at that. We're not even going to have any to do for homework, just a few. Okay, the graph of a function f is above. What do? Highlight this thing. This is the bona fide f function now. Okay.
Bona fide is 2 words. No, I swear it is.
Yeah, it is.
Yeah, isn't that weird?
I feel like we've been over this.
Yeah, she told us that. We thought it was one, and then she told us.
No, I don't think. Oh, did we?
So she told us.
It's probably in a screencast somewhere.
We have the receipts.
She went over the word.
You have the
Latin
proof.
word.
It's bona fide, in good faith. Yeah, okay. All right. So, okay. The graph of a function is at which value of x is f continuous but not differentiable? What do you guys think? A. A is a, no, corner. It's not like a corner, it is a corner. A.
And if it was opposite, it would be
If it was not continuous but differentiable? Yeah. B. Yeah. Yeah. Good. Oh, look at you. Okay. All right. Oh, dy dx. What are we doing here? Product rule. So, u prime 2x v sine 2x plus u v prime 2 sine 2x. No, 2 cosine 2x. All right, let's do this. So u v prime is cosine 2x times 2. And look, so it looks like they factor out a 2x. Let's do the same. So I get sine of 2x plus x cosine 2x. Huh? Did you say B?
I got C.
Oh my.
It's E.
It's E.
What's the difference? Oh, minus.
Ah, see? Don't always go for the first one. Look through all the choices.
That's a right answer.
And look, they know. They know that a student will miss the X here. They know, so they put that first. They're wise.
No, I put that X.
But yeah, Oh.
I wonder what's like the percentage of students who actually know how to do it and they get the right answer, but then just because of the wording of the problem, they
So derivative given by f prime is this. On which of the following is f decreasing? So f decreasing means f prime is negative. Okay? And look, you're given f prime here. The only thing is, so x squared minus 2 over x is equal to 0. So x squared is equal to 2 over x. X cubed is equal to 2. X is cube root of 2. But not only do I want that, okay, this is where f prime of x is equal to 0. But I also want where f prime of x is undefined, which is x equals 0. So to figure out whether or not a function is increasing or decreasing, remember I need to put it on a number line. And so here I get 0 and cube root of 2. So f prime, right, we're going to plug it into the original f prime, is, so at negative 10, it's positive, then negative, then positive. I don't know. I don't know how a student will get that. Maybe if you integrate, I don't know. But we do know that it's this one, D. Yeah, I actually don't know how you get a negative 1. Well, which is good, because it means, whatever trap they were trying to pull, we're not in there. Okay, so let's stop here. It's already 10:17. We're having way too much fun. So for homework, I want you to do the rest of these only until number 28 for tomorrow.